So here we have overlapping triangles with the bases being parallel. Last lesson you learned that since these angles are congruent by corresponding angles, and this top one is congruent by the reflexive property, these triangles are similar by angle similarity. A unique feature of similar triangles is the fact that their sides are proportional. So with this known, you can do the whole side and put it over the smaller side since they overlap. Now you have x plus 5 over x. Now take this side and set it equal to the other side, which is 8 plus 12 over 8. Now you have x plus 5 over x, which is equal to 8 plus 12 over 8. When you solve this by cross multiplying, you will get the answer.
Where's his 6?
Unfortunately, you wouldn't want to always put the whole piece over the small piece since that would be a lot of work. There is another way that I will show you now.
Here we have two similar triangles again with parallel bases. So a proportion of the two sides would be AB, or in this case, AD plus BD over AD, which is equal to, like we did last time, AC over AE, but in this case we want AE plus EC over AE. So now we can split these fractions using algebra, because if you have 3 over 7 plus 4 over 7, that would make 7 over 7, which you can then split again. So we can do AD over AD plus BD over AD equals to AE over AE plus EC over AE. Now, you see how we have AD over AD and AE over AE? Those two cancel out to form 1, which basically means nothing. Yeah. So now you have BD over AD and EC over AE. Now if you look again, you have the smaller part over the the other smaller part equals to the small part over the other smaller part of the other side, and this is called side splitter theorem. This will work on any two similar triangles with parallel bases and completely overlap. But note, the bases themselves don't work with these theorem. You would have to do it the traditional way. And that's it.
Now that we proved side splitter theorem, we're able to use it in a triangle proportionality problem instead of the traditional method. So with side splitter theorem, we're able to use x over x plus 5 equals 8 over 12. Then we're able to cross multiply. And subtract 8x and divide both sides by 4. and we get x equals 10. This method is much faster than the traditional method.
Pause the video now for the practice problem 1 of 2. But if not, we're going on to the answer right now. So first you want to add AB and BD, so 3, and then you want to put that over AB, which is 2, and then have that equal to 1, which is from the bigger triangle, over x from the smaller triangle. Then you can cross multiply, so it would be 3x equals 2, and then x would equal 2/3. That's the first practice problem's answer. This is practice problem number 2. We are going to be solving for x, and if you want to do this problem, pause the video now. If you want the answer, continue watching. So we are going to put 22 over 14, and then we are going to make that equal to 30 plus x over 30. And this would then mean that 30 times 14 equals 420 plus 14x, which then 22 times 30 equals 660. And then you would then subtract 420 by 660, which equals 240, equals 14x, and you would divide by 14 on both sides. You would have x equals 17.14 if it's rounded to the nearest hundredth.
That is it for 7-3, proportions in similar triangles. See you guys later.